right. Today and tomorrow, we are going to talk about triangle similarity. So, we spent a few days talking about congruency, and there's 5 congruency theorems. Today and tomorrow, we're going to talk about triangle similarity. So, similar in same shape, but just similar size. One could be big, one could be small. So, here we go. Similarity. This is my symbol for similarities, like a little squiggle. Okay. There we go. So similarity. My little squiggle there. So similar figures have the same shape, but not necessarily the same size. So same shape, but not necessarily the same size. Figures are similar if, 1, their corresponding angles are congruent, and 2, corresponding sides are proportional. So if their angles are congruent, then they are similar to each other. Or if the sides are proportional, so after we match up corresponding sides, they reduce to the same fraction, the same ratio, then we would say that they are proportional to each other. Right. Example 1. Are the figures similar? If so, write a similarity statement and give the similarity ratio. So we want to match up corresponding sides and reduce the ratio and see if it's the same ratio. If it's the same, we say yes, they're similar. And if it's different, we say no, they aren't similar. So I see that FG corresponds to LM. So if I set that up, 10 corresponds to 26. Let's match up something else. I see GH corresponds to MN. So that would give me 14 over 38. So what we're doing is asking ourselves, do these reduce? So I put a question mark on top. Do these reduce to the same thing? So let's see. 10 over 26 reduces to 5 over 13. I divided everything by 2. And 14 over 38 reduces to 7 over 19. I reduced everything, divided it by 2. These two ratios are not the same. One is 5 over 13, one is 7 over 19. These do not equal each other. So these first 2 rectangles are not similar to each other. They don't have corresponding angles that are congruent, and they don't have corresponding sides that are proportional. Let's take a look at B. I got 2 triangles here, so I want to match up some corresponding sides. So I see that if I start with BC, so you might have to imagine that this triangle is flipped so that we match up our parts, but BC corresponds to DE. So I'm going to set that up as 6 over 3. Let's choose another side to set up. Say we choose AB. AB corresponds to the base of my triangle, which is EF, and that's 4. So that corresponding ratio is 8 over 4. Now I will reduce these. Again, put a question mark on top. We're trying to see, are these congruent to each other? So 6 divided by 3, 8 divided by 4. They are the same, so we say yes. And the ratio is 2 to 1. Ratio is 2 to 1. So where did I get this ratio from? Well, 6 divided by 3 is 2, and my denominator, even though we don't see what the denominator is, my understood denominator is 1. So yes, they are similar, and the ratio is 2 to 1. C. So I'm going to separate these 2 triangles. So I see this little triangle here, and I got a big triangle. So I'm going to separate them so I can see them a little better. So my little triangle, the sides of my little triangle are all 3. So 3, 3, 3. So what I did was pulled out this little tiny triangle and separated it so I can see 2 separate triangles like I did for this one. Just maybe will it help us to see a little better. You may not need to, but it may help us to see a little better. And I'm going to do the same thing with my bigger triangle. I see my base is 8. 3 plus 5 is 8, and 3 plus 5 is 8. So instead of these 2 triangles being inside of each other, I pulled out the little triangle and I pulled out the big triangle. Now if I set up my ratios, hopefully you see that 3 corresponds to 8 on all sides. 3 corresponds to 8, 3 corresponds to 8, 3 corresponds to 8. So if I set that up, even though this is a tedious step that we don't really need, clearly we see we're going through the process though. We set up our ratios, we reduce them and see, yes, these reduce to the same thing. So yes, these are similar and our ratio is 3 to 8. So our ratio is 3 to 8. So that is how we figure out if figures are similar. And this is also how we figure out our ratio. Reduce your fraction, numerator, denominator, and make sure it's in reduced form. Okay, let's see what else we got to learn. Just as with proving triangles congruent, there is a shortcut method for proving triangles similar. The shortcut is the angle similarity postulate. So angle similarity postulate. That'll help us figure out if two triangles are similar because they have the same angle. So remember, we got two criteria to determine if figures are similar. Number one is corresponding angles are congruent, which is what we are about to investigate down here. And then number two, corresponding sides are proportional, like we just did up here for example 1. So now we're going to get into if the angles are congruent to one another. So 2A, I see that this angle corresponds to this angle because they both have one tick mark. I see that this has 2 slashes and this has 2 slashes. So by default, this one must be the same as this one. So now my angles are congruent. All 3 angles are congruent to each other. So yes, these are similar. So not only do we need to figure out that, but we also need to find the value of x. So we're going to set up some ratios. 8 is my base and 12 is my base. 6 corresponds on this side and I'm looking for x. So we did 8 over 12 is equal to 6 over x. So make sure you're keeping the same order as you're lining up your ratios. From here, we cross multiply and divide. So cross multiply. So I made an x cross multiply. 8 times x is equal to 12 times 6. 8 times x is equal to 12 times 6, which is 72. So I made an x. 8 times x is 8x. 12 times 6 is 72. And the opposite of multiplying by 8 is to divide. So I got x equals 9. X equals 9. So that is what x is equal to. 2B, again, let's see what we have. I have one angle that I know is congruent based on the given tick marks. I also see that these are vertical angles. So 1, 2, 1, 2. I see that those are vertical angles. So by default, if this is the same angle, that's one angle. This is the same angle, that's 2 angles. By default, these 2 angles have to be the same. So whatever this angle here is the same as this measure here. So 1, 2, 3, 1, 2, 3. So if I match up, so this would be yes. Okay. If I match up my ratios, doesn't matter if you start with 24 or 22, just make sure you match up your corresponding parts. So 22 is actually going to pair up with x. So again, you might have to imagine that I took this triangle and flipped it so that they're facing the same way and going the same direction. 22 actually matches up with x. So 22 over x. And so that means that 24 corresponds to 14. So 22 over x is equal to 24 over 14. We're going to cross multiply. So all this is about cross multiplying. So I'm going to make an x here. I'm going to cross multiply. 22 times 14 gives me a pretty big number. So after I went ahead and cross multiplied and divide, I did get 12.83. So you are more than welcome to use a calculator. So I did 24x is equal to 22 times 14. And then I took this number and I divided it by 24. So I got a decimal. It didn't work out pretty, so to speak, like the first one, but that's okay. We can use Desmos to help us simplify this. So 24x is equal to 22 times 14. Multiply this, divide by 24, and I got 12.83 repeating. So you are more than welcome to use Desmos or your calculator to help you with that. Let's try one more. If I look at C, I don't necessarily have enough information to know that these are similar. However, I still do have enough information to figure out that what X is equal to. So I know that these are parallel lines, and I do have some alternate interior angles in here. So they actually are similar. My angles are going to be the same. So I would say yes for this one too. So I'm going to pull out my two different triangles like I did for the first one. So this is a triangle that I'm going to pull out just so that they are not right on top of each other. So you may be fine looking and visualizing, but this is just a strategy to use. Instead of looking at one triangle, you can look at two separate triangles. And this is 6, and this side over here is 5 plus x. So all I did was just separate my triangles so I can see them a little better. So I am able now to find what x is equal to. So 5 corresponds to 5 plus x. So I'm going to set that up. 5 corresponds to 5 plus x. And I know that 4 corresponds to 6. All right, we're going to do our thing just like we did for 2a and 2b. We're going to cross multiply. So I'm going to do 5 times 6 and then 4 times this one. So I will make sure I show my work for this one since I have a variable in here. So 5 times 6 is going to give us 30. And we need to do 4 times 5, 4 times x. So we're doing the distributive property. 4 times 5 and 4 times x. So that's going to give me 20 plus 4x. So this is a positive 20. We're going to subtract 20 from both sides. Opposite of multiplying by 4 is to divide by 4. Reduce your fraction. I got 5 halves. So x is equal to 5 halves. So now we've gone through and we've talked a little bit about number 1 up here that says corresponding angles are congruent. And we did a little bit with number 2, which says corresponding sides are proportional. So that's how I can figure out if two figures are similar. Now, there's also some proportions in similar triangles that'll help us figure out the value of x. So there's 4 different rules that we can use to help us figure out the missing side length of a triangle if I know that they are similar. So rule number 1 says that A over B is equal to the same ratio as C over D. So A over B is equal to C over D. So if you see a picture, if you see triangles that look like this, A over B is the same as C over D. And also, if I see a picture that looks like this, something else that I know, E over F is equal to C over C plus D. So E over F is equal to C over C plus D. So if I see a picture that looks like this, rule number 1 says that the following proportions are true, and it'll help us find a missing side length. And of course, we'll do some examples after we go over these 4 rules. Rule number 2 says that A over B equals C over D if you have parallel lines that are cut from a transversal. A over B is equal to C over D. Rule number 3, same thing. If I have a picture that looks like this, my same ratio applies. It's just that the picture is changing. And then the last rule, rule number 4, says that E is equal to 1/2 times F. So E is equal to 1/2 times F. And this is a mid segment. So a mid segment means that this line cuts this side of my triangle in half. So if this side is 5, this side is 5. If this side is 3, this side is 3. So line E is a mid segment. It cuts this side of my triangle in half and this side of my triangle in half. Now let's use these 4 rules and we are going to find some missing side lengths of triangles using these 4 rules. So keep these 4 rules out in your notes, index card, note sheet. Just make sure you keep these out as we go through when we try some problems. All right. All right, find the value of x. So looking at this first picture, I want to go back and look at my rules and see if this looks like rule 1, rule 2, rule 3, or rule 4. So I'm going to try to put these in the frame at the same time. Let's see, let me try to fold my paper here so that we can see. All right, so I got my rules here. All right, I got those 4 rules, and then we're going to take a look at. All right, there we go. So we can kind of see everything at the same time. So this picture to me looks just like this picture. So this must be the rule that I'm using. So different numbers, it is flipped a different way, but these 2 pictures look very similar to each other, except for I have numbers here. So I'm going to set up A over B is equal to C over D. And it doesn't matter which one you use which, but I am going to follow this formula. So if I follow, it says X over 10 is equal to 20 over 8. So it said that one side, I set those on top of each other, A and B, and then I set C and D on top of each other. So X and 10 go together, they're on one side of the triangle, and 20 and 8 go together, they're on the other side. So we cross multiply and divide. It's going to be a lot of that in this section, cross multiply and divide. So 8 times X is 8X. 20 times 10, and then divide. Again, Desmos mental math calculator, we got 25. So the answer to number 1 is 25. And let's also put out which rule we use just for studying purposes. So we use rule number 3. So rule number 3 from the first part of the video helped us solve A. All right, let's take a look at B. So which picture matches up here? Let's see, we got 4 different options. This picture looks like rule number 1. So different numbers, one side's a little more slanted than the other, but very similar. So let's put in that this is going to be rule number 1. Now, nothing is given in the middle section here, so I don't have to worry about using this side up here that I'm kind of air circling. I don't have to worry about using this side because I don't have any numbers here. So we're going to be using A over B equals C over D. So my ratio is going to be 8 over 10 is equal to 6 over X plus 2. 8 over 10, that's one side, is equal to 6 over X plus 2. So we're going to cross multiply and divide. So we're making an X, or cross multiplying and dividing. So I'm going to do the distributive property. 8 times X, 8 times 2. 8 times X is 8X. 8 times 2 is 16. 10 times 6. We're going to go through and solve this equation. So subtract 16 from both sides because that's the opposite of adding. And the opposite of dividing by 8 is to multiply. I said it backwards. The opposite of multiplying by 8 is to divide by 8. And you get a fraction. You get a decimal, but there's nothing wrong with that. Let me slide up a little bit. So you get a fraction or a decimal, but there's nothing wrong with that. So 44 over 8 reduces to 11 halves, which is 5.5. And I went into the next box there, but that's all right. So I used rule number 1, which says to do A over B equals C over D. So this side, set it equal to this side. You set up your ratios, you cross multiply and divide. Let's take a look at C. Okay, C looks rather complex, so I need to see which rule that I'm using. This definitely looks like rule number 2. So it definitely looks like rule number 2 up here that I'm underlining. It looks like this. So that's the one that I'm going to be using. So in this box, I'm going to say rule 2. So if I set up my ratio, it's still A over B is equal to C over D. I want to make sure I line up everything correctly. So one side is 5 over 6 is equal to 4 over this missing side. Now, I don't know what this is, but I know that the whole thing is x. So if I take away 4, it'll give me what's missing here. So this missing part here is x minus 4. So again, I didn't know what this is, but I know the total size. So you find what's missing by just subtracting. So x minus 4 will give me whatever this missing number here is. We're going to cross multiply. Okay, so we're going to cross multiply. 5 times x and 5 times negative 4. That's going to give me 5x minus 20. And 6 times 4 is 24. All right, we're going to add 20 to both sides. So 5x is equal to 44. You're going to get a fraction. That's all right. Divide both sides by 5. X equals, you can leave it as 44 over 5 or as a decimal. So I'm going to do both. 44 over 5, which is 8.8. All right, I got 3 more I want to take a look at, so I'm going to get rid of the rules. Hopefully, you still have those handy as we take a look at 3 more problems. I'm still going to go through and label if I'm using rule 1 or rule 2 or rule 3. Just wanted to slide up a little bit, give myself some more space. All right, let's take a look at 3D. 3D, we're going to be using rule number 1. Very similar. Looks very similar to B. So this is rule 1. So your ratio is A over B is equal to C over D. So A over B is equal to C over D. And we're going to cross multiply and divide. You don't have to put these like little oval circle things there. Just doing that so that you know that we are making an x. So 12 times x, and then 12 times 4, and then 9 times 2x. So 12 times x is 12x. 12 times 4 is 48. 9 times 2x is 18x. We go through and solve our equation. We need to subtract 12x from both sides. So I'm not going to write that stuff because I'm running out of space here, but subtract 12x because that's the opposite of a positive 12x. So subtract 12x, subtract 12x. That gives me 6x equals 48. And the opposite of dividing by 6 is to multiply both sides by 6. So 8 is equal to x. So that missing side that we need is 8. 2 more to go. Letter E. We haven't done this rule yet. We did a rule 1, rule 2, and a couple of rule 3s. Let's take a look at this one. This is going to be rule number 4 because I'm giving something here as far as my mid segment goes. So this is rule 4. Rule 4 says E is equal to 1/2 F. E is equal to 1/2 F. So when I set this up, x plus 5 is equal to 1/2 times 18. So E is equal to 1/2 of F. So x plus 5 is equal to 9. Subtract 5 from both sides. X is equal to 4. And last but not least, letter F. Letter F is another rule 1 problem just based off of the way that it's set up. So you do not have to identify the rule, just doing that just to, since we're just starting, so you'll know where I'm getting these rules from. So this is rule number 1. So I'm going to do x over 18 is equal to 6 over the sum. So 6 plus 10. So x over 18 is equal to 6 because 6 corresponds with the little triangle. And then this whole side corresponds with the big triangle. Of course, I can clean this up, just letting us get used to the setup. So once I clean this up, x over 18 is equal to 6 over 16. We're going to cross multiply. So this is going to give me 16x is equal to 108. Divide both sides by 16. So divide both sides by 16. So if you reduce this fraction, I got 27 over 4, which is approximately 6.75. So 27 over 4, which is approximately 6.75.